Question 16a. Complete the sentences about an atom. Use the words from the list. At GCSE, we consider the Rutherford model of the atom, which looks a bit like this. Our nucleus and then a tiny electron zooming around it. Having a look at the sentences we're asked to complete, we can see that an atom has a something charged, so positive, negative, neutral, this kind of stuff there. So this is going to be some kind of descriptor for charge. It's talking about a nucleus, our electron's negative, so overall positively charged nucleus. There we go. Don't know why I bothered crossing it out. I could use that word again, but just keep a track of what I'm using. Surrounded by something charged electrons. Okay, well, kind of said that already, so negatively charged electrons. Nucleus contains protons and something else. Well, if it's surrounded by negatively charged electrons, they're not going to be in it. What are the other particles that are inside? Atom, electrons, neutrons. Yep, almost all the mass of the atom is in that big bit in the center here. This is our nucleus, so nucleus there. Since our neutrons and our protons are in that nucleus, and they're pretty big compared to an electron. 16bi. A swimming pool contains 9,970 kilograms of water in 10 meters cubed. Calculate the density of water. They've handily given us an equation to use, but we might as well use the physics algorithm to see what we've got to play with. So, mass, 9,970 kilogram. It's a standard unit, we don't need to convert that. 10 meters cubed, that's our volume. 10 meters cubed there. And meters is our standard unit of measurement, so meters cubed, standard unit for volume. Don't need to convert that. Happy days. And then we have density equals that. So density equals mass, this one here, 970 times 10 for our volume. Whoops. Goodness me, I need a coffee. Divided by 10. Pretty handy that they've given us an equation to work with. Well, dividing with 10, we get rid of one of those zeros, 997. So density equals 997 kilograms per meter cubed. According to the metric system, a ton of water is the amount of water that you get in a meter cubed of water, and that's about 1,000 kilograms. So this answer passes our sanity check. Question 16bii. The diagrams A, B and C show the particles in 3 states of matter. Here we go. Write the letters in the box to give the correct order of density from most to least dense. Okay, most means lots of stuff per volume, or at least in this 2D diagram per area, and least dense is less stuff per volume. Okay. If we were to look at these 3 diagrams, there is a set area, this box here. C has more spheres or circles per box, and then B has slightly less, and A has only 4 circles in that box. So that gives us an idea of the density. Most dense is therefore C, followed by B, followed by A. Question 16bii, or B3. Explain why you chose this order. Well, basically I want to paraphrase these notes that I made here. Why did I choose C to be the most dense, for example? C is most dense as there are more, let's call them particles or spheres, particles in a given volume. Let's further solidify that answer. A has much fewer particles for same volume. Goodness me, my handwriting's awful, but hopefully you've listened to me narrate. So that's basically what we were saying here. We've got more particles per volume, and for the same amount of space here, this square, A has the least. B sits in the middle. Blank page. Please do not write on this page. If any of you are wondering why this page exists, it seems a bit of a waste. It's so that when you've got to the book version of this exam, you end up with the right kind of information in front of you. So examiners write their exams with deliberate blank pages like this, so that for some key questions you don't have to go back and forth over a page turn to get the right kind of information for a question. So it seems a bit of a waste, but it's actually to help you get the right information in front of you for each question that you're trying to do.